For much of the last decade, the green hydrogen conversation has been driven by technology promises and scale announcements. Electrolyzer efficiency targets, gigawatt roadmaps, national hydrogen strategies, and ambitious net zero pledges dominated the narrative. The assumption was simple: once the technology matured and enough capacity was announced, the rest would naturally fall into place. But as the industry moved from vision to implementation, that assumption began to unravel. The reality that emerged was far more complex. Technology alone was never the main constraint. Execution was. That is why ITM Power's recent announcement, securing engineering contracts totaling 70 megawatts of green hydrogen projects across Australia and Canada, matters far more than the number suggests. In an industry that is moving past hype and into delivery, engineering contracts are one of the clearest signals that projects are real, progressing, and being designed for actual operating conditions. At first glance, 70 megawatts may appear modest compared to the gigawatt-scale hydrogen hubs that still populate conference slides and government roadmaps. But the hydrogen market of today is no longer rewarding ambition without discipline. Investors, off-takers, and policymakers are demanding evidence of execution capability. They want to see projects that can move from feasibility to construction without collapsing under cost overruns, delays, or unrealistic assumptions. In this environment, engineering work has become more valuable than headline capacity announcements. Engineering contracts indicate that projects have passed key gates. Preliminary feasibility has been completed. Grid access and power sourcing have been evaluated. Water supply, safety systems, and integration requirements are being addressed. These are not speculative ideas. They are projects entering the phase where real design decisions are made and real capital is committed. Execution tools are critical at this stage, but they only work if the project itself is properly designed. One of the biggest challenges in green hydrogen today is that teams often jump straight into execution without fully understanding hydrogen-specific feasibility, cost drivers, risks, and project structure. That is why we built H2 Hub at h2hub.renienergy.com. H2 Hub is a training platform for green hydrogen project development that also includes practical tools and templates. It helps developers, engineers, and consultants learn how to design bankable hydrogen projects before they ever open a scheduling or execution tool. This distinction matters because execution failures are often blamed on construction issues when the real problems were baked into the project much earlier. Unrealistic electricity price assumptions, misunderstood electrolyzer utilization rates, underestimated balance of plant costs, or weak offtake structures can quietly undermine a project long before ground is broken. No scheduling software can fix a fundamentally flawed project design. This is where ITM Power's role becomes particularly interesting. The company is not just supplying electrolyzers, it is embedding itself in the engineering phase of projects. Engineering services involve system integration, balance of plant design, and optimization tailored to specific sites. Electrolyzers do not operate in isolation. They must be integrated with renewable power generation, water treatment systems, compression and storage infrastructure, safety systems, and downstream users. Each interface introduces technical and schedule risk. Managing those risks requires disciplined coordination. Hydrogen projects involve multiple parallel work streams: civil works, electrical infrastructure, procurement, permitting, commissioning, and grid interconnection. These activities are interdependent, and delays in one area can cascade quickly across the entire project. This is why structured scheduling and dependency tracking are essential once a project enters execution. This is also where tools like Microsoft Project remain widely used in energy and infrastructure development. They provide visibility into timelines, critical paths, and dependencies across complex projects. If you are coordinating electrolyzer delivery, EPC contractors, and grid milestones, this level of control is not optional. You will find a link to Microsoft Project in the description if that is relevant to the projects you are working on. Using the link supports the channel and helps us continue producing in-depth, independent analysis. Returning to ITM Power's announcement, the geographic diversity of these contracts tells an important story. Australia and Canada are very different hydrogen markets, yet both are moving toward more pragmatic deployment strategies. Australia has long been positioned as a future hydrogen export powerhouse, but many early export-focused projects have been reassessed. Developers are now prioritizing domestic industrial demand, stage scaling, and realistic offtake agreements. Engineering contracts in this context suggest projects that are designed to be built, not just announced. Canada presents a different set of dynamics. Access to renewable electricity, proximity to industrial demand, and integration with U.S. markets make it attractive for green hydrogen development. At the same time, projects must contend with colder climates, regional grid constraints, and complex regulatory environments. Engineering involvement at this stage indicates that these projects are being designed for real operating conditions, rather than idealized assumptions. Another point often overlooked is that 70 megawatts usually represents multiple projects rather than a single facility. Each project contributes operational experience, technical data, and institutional learning. This is how electrolyzer companies adapt to a more disciplined market. Instead of relying on one massive high-risk development, they build portfolios of deliverable projects that strengthen execution capability over time. From a financial perspective, engineering contracts also provide more stable revenue than equipment-only sales. In a market where electrolyzer orders can be delayed or renegotiated, engineering work helps smooth cash flow and keeps technical teams engaged. For technology providers under pressure to demonstrate commercial traction, this kind of work is strategically important. For developers watching this space, there is a clear lesson. Many green hydrogen projects do not fail during construction. They fail much earlier. They fail because teams misunderstand hydrogen economics, underestimate integration risks, or rely on assumptions that do not hold up in real projects. This knowledge gap is exactly what H2 Hub is designed to address. Through structured training and hydrogen-specific tools, H2 Hub helps teams understand feasibility, risks, and project structure long before execution begins. When that foundation is solid, execution tools like Microsoft Project actually work as intended. This shift toward execution discipline is reshaping the entire hydrogen ecosystem. Feasibility studies are becoming more rigorous. Timelines are becoming more conservative. Stakeholders are demanding clearer visibility into risks and mitigation strategies. The industry is learning that hydrogen is not just another renewable technology. It is a complex industrial system that requires careful planning across technical, financial, and operational dimensions. ITM Power's engineering contracts are a quiet but powerful signal of this maturation. They suggest that developers are no longer chasing scale for its own sake. They are focusing on projects that can survive scrutiny, attract financing, and deliver real outcomes. This is a healthier phase for the industry, even if it generates fewer headlines. For ITM Power specifically, being involved at the engineering stage allows the company to influence system design and demonstrate real-world performance. Over time, this builds trust with developers and investors. In a crowded electrolyzer market, execution capability becomes a key differentiator. For the broader hydrogen transition, the implications are clear. The future of green hydrogen will not be defined by who announces the largest capacity. It will be defined by who can deliver projects reliably, on time, and within budget. Execution has become the real battleground. If you are serious about developing green hydrogen projects, not just following headlines, you need two things. First, the right training and framework to design the project properly. That is what we focus on at H2 Hub, a green hydrogen project development training platform with practical tools and templates, available at h2hub.renienergy.com. Second, disciplined execution, where tools like Microsoft Project help manage timelines, dependencies, and delivery. Both matter, and they serve different roles. This separation is important. Training builds capability. Execution tools deliver outcomes. Confusing the two is one of the reasons projects struggle. When teams understand this distinction, they dramatically increase their chances of success. As green hydrogen continues its transition from vision to infrastructure, expect fewer oversized promises and more quiet progress like this. Engineering contracts may not dominate headlines, but they are the signals that matter most. They tell us which projects are moving, which companies are adapting, and which parts of the industry are learning how to operate in the real world. ITM Power's 70 megawatts of engineering contracts do not represent the future on their own, but they represent something equally important: momentum built on discipline rather than hype. And that is what the hydrogen sector needs if it is ever going to move from promise to impact.